Well, I appreciate everybody for coming. I think, again, not an AI talk, but I appreciate, again, everybody's time. We're going to talk about a subject very near and dear to my heart when we talk about industrial control or OT, cybersecurity. I probably, in some ways, suckered everybody because the original title of the presentation was How Do We Secure Critical Infrastructure? And I had a really great presentation I do through my office, and it's very, I don't know, straightforward. I mean, it's great information. And then I realized 2 days ago, I wanted to blow it all away and start with something else. So we're still going to touch on the same content, but just from a little different aspect. And I think it'll be probably a little bit more fun. And so I came up with, yes, things we say or I say to piss off, I call them the cranky old white guys in the control system community, right? And you find them everywhere, and we'll talk a little bit about that as we go on. So please, everything we talk about, just hold it against me, not my companies that I work with. So just a little level set, just so you know a little bit of who I am. So my name's Mike Holcomb. I'm the Floor Fellow for Cybersecurity. For those of you that know Floor, we're one of the world's largest engineering and construction companies in the world. I'm also the practice lead for ICS OT cybersecurity. So I actually do get the advantage of working in some of the world's largest ICS OT environments. So you see in the upper left was my very first project, which was the largest traditional power plant in the Western Hemisphere, which was where I fell in love with power. For the very first time. I got to work on the new New York Bridge. I got to do offshore oil rigs for Shell. And then our largest project right now for Shell, and our largest project, their largest project, is a $50 billion LNG port facility up in Canada where any Gold Rush fans? I used to be a Gold Rush fan. So it's actually like literally 2 miles from where they filmed Gold Rush, which is really cool. The really exciting thing about this, it's actually really a small town. It's almost like a medium-sized town. You kind of see the tank where we store the LNG down below. That's the size of a large sports arena, just to kind of give you an idea of the size and scope. So when we first started talking about it from a risk assessment perspective and talking cybersecurity, I wasn't thinking as big as that. So that's a little bit about me and what I do. So a main focus for me, especially these days, is working in different environments with different clients and getting owners and operators to understand they are targets, right? ICS security reminds me of IT security 20 years ago. Nobody thought they were a target when we were all sitting ducks, and that's very much the same for OT these days. And if you're not familiar with the ideas, the owner it's the company that owns that facility, right? So if we're talking about that Dominion Energy power plant, Dominion Energy is the owner of that facility. You have the operators, that's a company that runs the power plant, right? Generates electricity to allow the owner to make money at the end of the day, right? So sounds straightforward. It's just weird when you haven't or you're not familiar with those terms. And so usually the owners and the operators are the same company, or they could be different, right? But real quickly, I want to talk about the 5 ways that attackers typically are going to get into the OT environment. And hopefully, if this is new to you, it'll make a little bit more sense in a couple of slides. But for now, I think the number one way attackers get into the OT network is through IT. And that makes sense, right? We have people in the back office, right? They're sitting in their cubicle, in their office. They're on the internet. They're browsing the internet, right? They're reading their emails, right? They're clicking on links. They're opening up attachments that they shouldn't be, right? They get infected. The attacker now has that foothold in IT, and it's just a matter of time before they move into the OT environment if a path exists. So we're going to come back to that. So we have this fancy term called transitory cyber assets that can be brought into the OT network. So we're talking about what are some examples of transitory cyber assets? Laptops, right? USBs, yeah, anything we bring into the environment. Like I said, fancy term just for, stuff we bring into the environment that we plug into systems that they could be infected and potentially give the attacker another foothold, right? That was Stuxnet, which we'll talk a little bit about. So I've seen, unfortunately, environments where you have the OT network or IT network, right, with assets that are exposed to the internet, usually accidentally, or somebody maybe did it on purpose, thinking they were doing the right thing, right? So we worry about that. We worry about remote access capabilities. Most OT environments today have remote access for people to come in to do maintenance remotely, whether because of COVID or we don't want to pay their travel, or there's a lot of environments that I don't want to be in to do maintenance on systems, right? It's just simply not safe. And so we love this idea of remote access capabilities, even if it's just a safety consideration, right? And then malicious insiders are really a big thing in the OT world. But the landscape changed, because up till Colonial Pipeline, so this was May of 2021, so about 2.5 years ago, right? Before Colonial Pipeline, OT environments only worried about what type of attackers? What was the one main group of attackers we were worried about getting into our power plants and our chemical refineries? Nation states, yeah, the advanced persistent threat, right? So it didn't matter if it was the Americans, the Chinese, the Russians, right? You're always worried about the APTs. And that's all you were worried about. Or with Colonial Pipeline, Colonial Pipeline wasn't a nation state that took down the United States' largest gasoline pipeline for 10 days. It was what? It was a ransomware group, right? Anybody remember the name? Dark Side. So I'm like, okay, I'm a Star Wars geek. I'll roll with it. I can appreciate it, right? The idea is it wasn't a nation state, though. It was Dark Side, right, sending out a bajillion emails to everybody on the face of the planet, trying to get somebody to click on a link or open up an attachment, infect their computer. And somebody in the back office at Colonial Pipeline, they did exactly that. Their entire IT environment burned completely down to the ground. And then Colonial Pipeline said, oh, we're going to shut down the OT network, right, which shut down the pipeline, and it was down for 10 days. And so there were repercussions, and of course, yeah, there was some money loss, but life got back to normal. But at the end of the day, well, guess what? All the other ransomware operators out there, they realized, oh, you know what? Well, we're in it to make money, so guess what? If we start targeting these environments, I bet we can make more money, right? And hacktivists, we've actually seen a big rise in hacktivism around OT environments. So all of our environments are becoming, not only are there more attackers now and different types of attackers, but the volume of attacks has just completely risen off the charts. So this was my original talk. And so this is where I had taken the idea of the critical security controls from IT. How many of you are familiar? Oh, usually there's a lot more, especially with usually the SANS crowd in Augusta, right? But the idea is, taking those critical controls in IT, but bring it into the OT world. So the idea, I love critical security controls because A, it was written in plain English so anybody could understand it, right? My mom could read the document and understand it, probably, right? So the other great thing about it, it was a prioritized list. So if I didn't have a cybersecurity program, then I know exactly where to start. And then I can work my way down the list as I have time and other resources like money. Right? And so when I was building our list, right, the idea was, what's the first thing, the one thing I can do if I only could do one thing to protect my OT network? Well, it would be put a firewall between IT and OT. And it doesn't sound very complicated. And there's a lot more. That's why there's a big bucket called secure network architecture. But that's the one thing where we would start. And then you can see we go from incident response and work our way down, and we'll touch on some of these. And there's actually 20, but we're just talking about the top 10 here, or the 5 I consider are the fundamental building blocks that everybody needs. And then if you want to move to a top-tier world-class cybersecurity program, you really want to do at least the top 10. So my story changes a little bit. So about 4 months ago, I actually started actively posting on LinkedIn. Any LinkedIn folks out here? And I just had joined, and yeah, I use it to keep in touch with people at, the office or people you meet at conferences. But I actually started posting content about OT and ICS cybersecurity. And what I did was, because when we look at how do we secure our environments, we don't have individuals that understand the whole big picture to do the job. Because if you go into a power plant, you might have somebody from IT cybersecurity that understands how we secure things like the network and protect the assets, but they don't understand the engineering aspect. They don't understand the physics of the environment. We have engineers and other OT professionals that understand the physics and how the plant's designed and how it runs, but they don't understand how to secure it. Right? So that's where we're in this world right now where we have folks like myself from an IT cybersecurity background learning the engineering aspect, and then we have engineers learning the cybersecurity aspect, but you really still don't have a lot of individuals that do both things. Right? I'm very lucky I get to work with the engineers that I do because I get to learn so much. The whole point is, and if you are looking at getting started into industrial or ICS OT security, I did a couple of free ebooks that right now, then I'll show you the links at the end. And then it depends on, are you coming from an IT cybersecurity background or are you coming from an OT background? What you'll see, and kind of this common theme we'll talk about, is there's so much overlap. 80, 90% overlap. It's just that 10, maybe 20% that it's very, very different. Right? So we want to focus on those commonalities. So this idea, things we say to upset the old guard in ICS. Right? ICS cybersecurity is just like IT cybersecurity. Now, I will not be that extreme. But you see that in ICS folks. They say, they're not the same. They're nothing alike. Like, for me, it's, well, no, I mean, they're actually more alike than not. Again, there's like 80, 90% overlap, which is awesome because you can take somebody from IT cybersecurity and you can put them in OT. And it's not going to blow up the power plant, right, or bring down the grid, which, as a lot of folks will kind of make it sound like. Right? So we have engineers on we talk about the OT side of the house. Right? And then, so maybe in the power plant, right? And then we have, well, on the IT side of the house, right, we have our IT cybersecurity folks. And the idea is, yeah, we allow these environments to communicate. We almost always need to, right? Unless there's nuclear something involved. Right? Otherwise, if I'm a power plant, right, if I'm an owner of that power plant, I still need information from the OT network to understand things like, well, how many or how much resources we're using to generate power. How much power are we generating, right? I want to, at the end of the day, know how much I'm going to be billing my clients for, right? How much money are we going to be making, right? So just a simple example, right? If I'm a manufacturer of pharmaceutical, right, I need to know how much we're generating, how much we're creating, so I can at least schedule logistics for shipping. So we need to get that information from OT over to IT. The problem is we talk about, remember, what's the number way that attackers get into the OT network? They come from IT. So then it becomes this whole adversarial mindset that if I'm in OT, I'm going to put up the walls and I don't want anything to do with IT. Right? You come near me and it gets really ugly. Right? That's what happens. That still happens in a lot of environments. The problem is when you have IT and OT going at each other, right? The only people that win are who? The attackers, because nothing's going to be secure. Well, it's really sad to see these environments. So a big part of OT cybersecurity is getting IT and OT to work together. Really, it's not a technical control. Right? When I got out of IT cybersecurity, for the most part, right, I thought I was done with security awareness. I do more security awareness today than I ever did in 20 years of IT cybersecurity. Because ultimately, it's not, right, the IT side of the house and the OT side of the house. It's we're all live in the same house. right? Let's protect the house, right? And let's protect, for me, right, it's ultimately around the world around us, right? If I have that power plant, right, if the power plant goes down, can we live without power for 3, 4, 5, 6 hours? Yeah, sure, not a big deal. But what if 3 or 4, 5, 6 hours becomes 3 or 4, 5 days, or weeks, or months, right? Then we get into like Walking Dead territory, right? Into the world, and you start to think of how, civilization, really does break down because we're all human at the end of the day. Right? So that's really what it's about for me. So we have to move past the pettiness. Really, is what it comes down to a lot of times. So we got to get people to talk together. The great thing is, overall, and I do not want to sound dismissive or put down the ICS community. The ICS OT cybersecurity community is incredible, and there are a lot of great, supportive people in it, most definitely. It's just like anywhere. There's a few bad apples that are out there, and that's partly what, generated or was kind of behind this presentation. Right? So I thought I was smart, and so we talk about the Permutu model can be used for cybersecurity. This drives the old school folks crazy. And so I found this out the hard way, and I thought I was being really smart. I put together this little series I was going to do, a post a week called What the Heck Is, right? Because in ICS OT, there's a ton of new acronyms, right? PLC, HMI, RTU, SCADA, right? SCADA, like what the heck are all these things? SIS, right? So it's like, and then it's, what the heck is the Purdue model, right? Because that comes up in almost every conversation we have. And so I woke up one morning, I was looking at LinkedIn, and I saw there was this gentleman, and he's a self-proclaimed ICS luminary. He's done a lot of great work in the community, and I saw that he reposted this to his group, and I was like, this is awesome. I was really excited. And then I read what he wrote on the post. He said, what the heck is the Purdue model? It's something that proves you don't know what you're talking about. I was like, my heart broke a little bit. I didn't cry, but my heart broke a little bit. I was just like, what are you talking about? And what he was talking about, and I'm going to go back, and this is the only picture I have of it, but the idea is the Purdue model, as originally designed 20 plus years ago. We actually had a floor engineer that was on the team that created the Purdue model, which is really, I can nerd out about. But the idea is it breaks down logically how systems in IT and OT, especially the OT network, talk to each other. Right? And that there's a logical division between IT and OT, right? The back office and the power plant, if you want, in our current example. And then it also gets into how we have all these other different systems that make up the OT network to allow that power plant to move in the real world and generate electricity. The Purdue model, no, it was not designed for security purposes. Completely get that, right? And no, it doesn't. And this is the SANS version of the Purdue model, which even has a DMZ between IT and OT, right? And they flip out because the Purdue model does not have a DMZ. Okay, I get that. The original Purdue model doesn't, right? We've all adapted it. I keep thinking is, when we, had cell phones first came out, and then someone came and said, right, we can add a camera lens and we can make this a camera. And then people were like, no, you can't. Like, why not? Right? So for me, right, the Purdue model, no, it was not designed for cybersecurity. Completely get that. But we use it for cybersecurity now, especially for those environments that, what if they don't have a cybersecurity program? There are a lot of OT environments out there that have no cybersecurity at all. I'm surprised there haven't been worse incidents. And there have been a lot. You just don't hear about them. Unfortunately, or fortunately, I don't know. So yeah, that's a little bit of my story. Normally I would dive into power plants a little bit, right? But the idea is, we have a power plant, right? And then it has this idea that, like in that power plant that I had worked in, right, we actually we piped in natural gas, right? You mix that in a combustion chamber with oxygen, right? You light it, it creates steam, or it heats water to create steam, which turns a turbine, which in turn goes ahead, turns a generator to create electricity, right? Okay, that makes sense. And then there's a lot of other things in there, but So this is a bird's eye view of the power plant. I was just using this to try to think, yeah, everything in the yellow line is essentially what we call inside, the battery limits, which is really, think that's the power plant. And then everything around it, those are all the ancillary services that we have. So remember, we're bringing in LNG, or natural gas, We're bringing in water, right? We have to heat water, so we're bringing in water, right? So we bring in those services. We have the back office, which is this kind of big white building on the right-hand side. The upper left-hand, or upper top white building, that's where the control center for the power plant is, right? You don't want your operator sitting in the middle of the power plant in case something goes wrong, but they have a nice big window so they can see if something is going wrong physically inside the environment. Right? But again, it's this whole idea of, we have the power plant, the OT network, and then we have the IT network, right? And we want them to communicate. It's just we want to be careful on how we design that communication and do it as securely as possible. And so this is actually my #1 viral post of all times. And this was actually only like 2 weeks ago, which was really cool. So you can see my cheesy little Visio diagram won the day. But the idea is we don't want to allow IT connections to originate and reach into the OT network. Right? Well, how do we get the data out? Well, we have OT send the data to IT, right? Because remember, if an attacker gets in the IT environment and we allow IT to reach into OT, right, the attackers, they're going to find that pathway and they're going to get into the network. It's as easy as that, right? And we know it's not a question of if, it's a question of when, right? They're going to get into the IT network, period, the end. So why are we then going to give them a pathway to go straight into the OT network? When if all we need is some OT data to do things like shipping logistics or understand the resource consumption or do things like predictive analytics. Allow OT to send to IT. IT, the business, they still get the data they need to get the job done. Awesome. But we're not leaving a path for attackers to get into the OT network. And I remember that was the first thing Rob Lee had focused on when the first time I talked with him. And the whole point, this vastly reduces, if you can do this and you can pull this off, that this vastly reduces the vast majority of your risk in an OT environment. Doesn't mean you're done, right? There's still a lot of other controls that we can talk about, and we're not even done with secure network architecture, right? Because that's just one layer between IT and OT. We're not even talking about when we get into things like zones and conduits, like further segmentation within the OT network, right? But for sake of time. So number 3, this is another one that just drives them crazy. So a PLC is just another computer. So this actually came up because when I was talking with the head of OT security for a large company, and we were talking about PLCs, and we'll actually talk about what they are in a second if you're not familiar. But the idea was, he said, well, they're not susceptible to buffer overflows, so we don't have to worry about protecting them. It was like, wait a minute, they have an operating system and they have memory and they process code, so why wouldn't they be? And so I had to pull up CVEs for actual known PLCs and actually show him before he believed me. So, and you're trying to do it the politically gentle way to do it. But if you're not familiar, the PLC is the most commonly used control asset or control system that we have. And so I'm just going to kind of jump ahead. They might look like this, especially in older environments, if you can see. In a newer environment like the ones we build at Floor, right, this is what you'll actually see. And so their point, and it's another one of those, where it's like we're all saying the same things at times. It's just looking at it different angles, and that's where people start butting heads. It's like, come on, we're saying the same thing. So this is a row or a bank of PLCs. These are ABB PLCs. The company's named ABB, the vendor, if you're not familiar. Right? So there's this gray, the first PLC, and then you can see a bunch of yellow ones. They're computers, right? Where, yes, they are different, and they're not like my laptop or my personal computer, is oh, there's these electrical wires running out of them, right? And yeah, sure, that makes them different from that perspective. And what are we doing with these wires? So they're actually what we call inputs and outputs. So with inputs, we can bring data into, or signals, right, into the PLC. So things like, oh, maybe I'm just taking a temperature, or the humidity or pressure level, maybe pressure in that LNG tank, right, sitting in Canada. So I can use that information to make decisions. Well, the computer, right, the PLC, makes those decisions. It's just like the thermostat you might have at home, right? You have what they call a set point, right? You say, how hot or cold do I want it to be in the room? I want it, okay, 72 degrees, right? If it becomes 73 degrees, the PLC says, oh, it's a little warm, so it's going to send a signal to the air conditioning unit to kick it on to bring the temperature down, right? And then it continually goes through what they call a control loop, right? It gets, oh, the temperature says, oh, it's back to 72. I'll send a signal to turn off the air conditioner, right? So it doesn't matter if it's your air conditioner at home or we're in a power plant and I'm sending a signal to that combustion chamber to say, ignite, right, this oxygen and natural gas mixture, so then we can then go ahead and, spin this turbine, which then ultimately, right, spins that generator and generates electricity. So, again, it's another one of those where, the PLC, is it a computer? Is it not a computer? For me, it's just another computer. Yes, it has these electrical wires running out of it, right, to bring in signals in the inputs and send signals on the outputs. But at the end of the day, it's a computer, and it's vulnerable to buffer overflows, right? So the one key, this is another one of those. It sounds so simple, but the best way to protect your environment, because when attackers get in the environment, the vast majority of the time when you talk about OT and attackers taking over, it's because they're getting into your PLCs and being able to manipulate them, to manipulate the physical process that they're connected to. So you can actually prevent that from happening by flipping a little switch. It's actually called a key switch in a lot of, so there's a physical key, or you have like a little dip switch, right, flip switch. And so you literally can just put it in what they call run mode, or makes it read only. So the PLC still does its job, but it can't be remotely updated. You can't change the programming, the logic. It can't be hacked until you flip that switch back to allow it to be programmed. The problem is a lot of people in environments, right, they make changes to the PLC and then they forget to flip the switch back. What my master thesis is on, so stay tuned for that if you're really, really curious. So anyways, so that brings us to the three things. Again, it takes all of us together to protect these environments. So, and I know he's not the first person to say this, but the best thing I ever heard Rob say was, yes, you do you, just don't be a jerk. And we can all protect our environments. So ideally, the attackers don't win. Right? So thank you, everybody. I really appreciate it. I know we got a couple of prizes to give away, but if you're curious, right, if you want to find me on LinkedIn, there's my email address for my side hustle. You can find me on YouTube and the GitHub, especially if you're looking for the books I was talking about. The IT one's out there. The OT-specific version is coming out next week. So I appreciate that, and I think we even hit the time perfectly. So